Okay, let's continue with measure of variation for variance and standard deviations. Okay, for variance and standard deviation, we have 6 different formulas. You can see here, the first one is a population formula. So population formula, we have population for variance, populations for standard deviation. Okay, the second one is a sample variance. So sample variance we also have for variance and standard deviation. But for sample variance, we have two different things. We have sample theoretical model, and the lower this one is sample computational model. So you can see the difference between these two sample variance formula. So this one is for theoretical model, this one is for computational model. Okay, for standard deviation, this one is for theoretical model, this one is for computational model. So my suggestions are you just memorize this formula only. Maybe you can memorize this formula, and formula. Because for the population, for the standard deviation, you just put square root here. So let's say if you memorize this formula, so you just need to remember that standard deviations, you just put square root. The same formula, but you just put square root. Same goes to this formula. You just memorize this formula and this formula. For the standard deviation, you just put square root. Okay. Okay, let's take a look on the example. Okay, this one, the example for population theoretical model. Okay, so here, find the variance and standard deviation for the dataset brand A paint. So we have 10, 60, 50, 30, 40 and 20. So this one is the value for X. Okay, so for the value for mean is 35, 35, 35, 35. Same. Okay, so to find the variance, okay, you need to take X minus with mean for each month. 60 minus with 35. Okay, so 10 minus with 35, you will get negative 25. So this negative 25, you need to find the power of 2. So negative 25 power of 2, you will get 625. This one also 25 times 2, 25 power of 2, you will get 126 also. So when you achieve all these power of 2, you just find the summations for this. So the summations for all X minus with mean over with, power of 2, you will get 125 plus 125 plus 225 plus 25 plus 25 plus 225, you will get 1750. So 1750, okay, put it here over n. So where do you get n? So n here is 1, 2, 3, 4, 5, 6. So n here is a number of X. Okay, so we have 6 months here. So X n is 6. So the variance is 291.7. So for the standard deviation, just put square root here, you will get 17.1. Okay. Okay, for this example, find the variance and standard deviation for the amount of European auto sales for a sample of 6 years. So the data are in millions of dollars. So you will have 11.2, 11.9, 12.0, 12.8, 13.4, 14.3 here. Okay, so we will know that the n value is 6 here. 6. Because 1, 2, 3, 4, 5, 6. We have 6 x. We have 6 values. So n. N is 6. So n minus is 1. You will get 5 here. So n here also 6. And then how to find the x? Summation of x power of 2. So for the summation x power of 2, take this one, x 11.2. The first thing is you need to find all the power of 2. So 11.2 power of 2, you will get 125.44. 11.9 power of 2, you will get 141.61. Until 14.3 power of 2, you will get 204.49. So, after you get all this power of 2, you need to find the summations. So, the summation is 125.44 plus with 141.61 plus with 166.41 plus 163.84 plus this one and plus this one. So the total summation is 958.94. So 958.94 put here. So how about the summation x? Power of 2 is outside the bracket. So for power of 2 is outside the bracket is you need to find the summation of x. So the summation of x, look at x here. 11.2 plus 11.9 plus 12.9 plus 12.8 plus 13.4 plus 14.3. So you will get the summation for all x is 75.6. So 75.6, take 75.6, put it here. Okay, so 75.6 power of 2, and then you will get how many here? Okay, so you just calculate all this, you will get the variance 1.28, for the standard deviation is 1.13. Okay. Okay, coefficient of variation. So coefficient of variation is x divided by mean times 100. Okay, you can see here, the coefficient of variation is standard deviation divided by the mean. So S here is standard deviation, X with the underline here is mean, time with the percentage. So percentage is 100%. Okay. Okay, look at the first example. So the mean of the number of sales of cars over a 3-month period is 83. So we know that the mean is 87. And the standard deviation is 5. Okay. The second one is the mean of commission is 5,225. So mean here is 5,225. And the standard deviation is 773. So compare the variations of 2. So here we have two different things. The first thing is a sale. The second thing is a commission. So for the sale, for the coefficient of variation for the sale, put the mean. Take the mean here. Mean is 87, put here. Standard deviation is 5. So times with percentage 100%, you will get 5.7%. For the coefficient of variation for the commissions, you will get 14.8%. So when this equation said compare the variation of the two, so you just put the results of commissions are more variable than sales. Okay. So measures of variation for Chebyshev theorem.